Hello, what's going on? Tomorrow is nostril sack. We did bit of work on that, but to help you, people have decided to do this question as well, right? Not this question, this sack as well. This sack is, as you know, uh, this sack is experimental based on sack. This sack is based on several experiment, right? Now we did a question already. In terms of this sack, now we are going to look at what? Question 2. Question 2. We are going to look at question 2. No, experiment 2. Is that okay? Experiment 2. That's what we are going to do. Now listen. This is a really annoying equilibrium system. Why I'm saying that? Because as you will see, this is an equilibrium system between the phosphoric acid and water. Now it's acid base reaction, and you have on top of that you have another indicator with the equilibrium system. So according to the concentration of H3O plus, look, I'll show you the equilibrium system. This is the equilibrium system. According to the concentration of H3O plus, indicator changes the color. Okay, look, have a look at that. This is the equilibrium system. H3PO4 reacting with water. In this case, H3PO4 is acting as acid. Water is the base, acid-base reaction. It is going to create H2PO4 minus and H3O plus. Okay. Now, that is the equilibrium system that we are going to focus on. But in that equilibrium system is also accompanied by another equilibrium system, which is an indicator. What does the indicator do? We have that indicator. Indicator changes its color according to the concentration of H3O plus ions in the equilibrium system. Is that clear to you? That's why we've got that indicator there. Now, before we start answering this question, it is important we understand the color, how indicator changes its color according to the concentration of H3O plus. Okay. Now, if you read this question, it says at very high concentration of H3O plus, high H3O plus concentration, indicator's color is yellow. Medium, it's green because it changes color from yellow to green. Then the low blue, very low violet. Is that clear? All right. So we need to mention those things aside of the question because we need to refer to those color changes. Now, going back to the observation, these are the two observations that we have done. We have heated this system, then the color has changed to blue. When the system is cooled, color has changed to green. Is that clear? All right, so we need to have that information ready before we start looking at the questions here, because it can be a little bit confusing. All right, let's look at the question here. Now we have to scroll down again. We've done those questions before. All right. Here, on heating, did the H3PO4 equilibrium system shift net forward or net backward reaction? All right, now heating. So heating, let's go and look at the heating part. Here. Where's that? Sorry. Heating, it changes to blue. Okay. Blue means low. Blue means low. So H3 ion concentration is low here means backward reaction has favored. All right. Is that clear to you? You have to be very, very careful. You have to refer to the color and then go back to the question. And according to the color, you need to decide whether the backward or the forward reaction has favored. All right. Going back to that again. On heating, it is blue. Okay, blue is the low concentration of H3O plus. Low concentration of H3O plus means the reverse reaction has favored. So the answer is backward or the reverse. So I'm going to go back here. So anyway, the answer is reverse or the backwards. See backwards here, or backwards. Backwards is the answer. Is that okay? All right, we got that done. Now the next question. Therefore, is the H3PO4 equilibrium system endothermic or exothermic? So on heating, in other words, when temperature is increased, system partially uh, oh, I lost it. Okay. When temperature is increased, system partially oppose the change by trying to decrease the temperature. So this is U. U increase the temperature. System partially oppose the change by trying to decrease the temperature. In order to decrease the temperature, system should favor the endothermic reaction. Endothermic reaction. So in this case, since the system has favored the backward reaction, we know that the backward reaction is endothermic. Therefore, forward reaction is exothermic is the answer. Yeah? Okay. So again, what do you have to say? It's exothermic. Why? When temperatures increase, system partially oppose the change by trying to decrease the temperature. Therefore, system favors the endothermic reaction. In this situation, backward reaction has been favored. Therefore, backward reaction is endothermic. Therefore, forward reaction is exothermic. Is that clear? All right, we got that done. All right, next question. Describe the color change of the system and explain what happens to the indicator when the H3PO4 heated. I don't know why are they repeating the same question. Anyhow, so if you heat it, what will happen? Forward reaction is exothermic. I think that this question is sort of repetition. So when it is heated, since the forward reaction is exothermic, system will partially oppose the change by trying to decrease the temperature. Therefore, reverse reaction is going to be favored. We know that. Reverse reaction is going to be favored. When reverse reaction is favored, look what happens. Going back to this. So when reverse reaction is being favored, have a look at that. H3O ion concentration decreases. H3O ion concentration decreases means violet becomes blue. So it is going to become blue. Oh, I think violet should be also correct, but if that was it going to decrease. So decrease means the reverse reaction is going to be favored. So H3O ion concentration going to go down. That is to say, it becomes blue. So my answer is, in this case, it is a bit annoying. I'm struggling to do this question because so many colors involved. So then I would say it's going to become shift to the blue side. Shift to the blue side as the blue side. Yeah. Blue side. That is what I can say here. Yeah, which is the blue side. Yeah, I'm trying to, which means that shift it backward. Yeah, so that makes sense. Which means the reverse reaction has been favored, because that is why it is favoring. It is going towards the blue side, because the reverse reaction is going to be favored because what? System partially oppose the change by trying to decrease the temperature. So endothermic reaction should be favored. That is the reverse reaction. So many colors. Huh? So many colors. Annoying. Huh? This is annoying. But what to do? All right, let's see. I think this is going to get better. If more H2PO4 added to the system, what color would the system do? What are we trying to do here? What is this? Sorry. What happens here? Okay, something happened, man? Okay, just give me a second. Okay, so here, if H2PO4 was added to the system, going back to the equilibrium. So let's listen. You are adding H2PO4. Okay, adding this. What are we adding? H2PO4 minus. So you are adding means again you are increasing the concentration of H2PO4 minus. So system will partially oppose the change by trying to decrease the H2PO4 minus. System should favor the net reverse reaction. Then again, it will change it to blue color. Man, why is all blue, blue, blue? This is annoying. Blue, blue, blue. Again blue. Is that clear? Again blue, because all these changes affected the system so that the system was favoring the reverse reaction. Anyhow, sketch on the graph below what would happen to the concentration of all the reactant product when H2PO4 added. Now, as you can see, it's 1:1, isn't it? Is it 1:1? Yeah. 1:1 is the thing. So what will happen if you add H2PO4? That concentration will go up, suddenly go up. Okay. So when it is go up, system will partially oppose the change by trying to decrease the H2PO4 concentration. So system should favor the net reverse reaction. Net reverse reaction. When net reverse reaction, do you remember what net reverse reaction is? Going back to, that's so annoying. Going back, so H2PO4 minus will decrease, H3O will decrease as well. 1:1 is the thing. So what happens? What happens? So here this will decrease. So let's say it's come to equilibrium at this time. I don't know what time is that, but so that's the equilibrium, new equilibrium. This is X. Let's say this is X. If that was X, this should decrease X as well, because 1:1 is the ratio, H3O plus. So oh, not so bad. So that is X as well. So then the equilibrium, this is X. So these will go up by X, yeah. Will go up by X, H2O, X. Sorry. That will go up by X. And H2PO4 minus will go up by X as well. H3PO4, sorry. And this is go by X as well. So that is done. Yeah? So annoying, isn't it? I'm taking a lot of time try to do this question. Yeah, I'm taking a lot of time try to do this question. Okay. Okay, it's liquid. Hey, by looking at this question, there is a bit of an issue here, but I don't think that, because H2O is a liquid, the state is liquid, so technically the concentration of H2O should not change. But this graph says that, so technically we should not, alright, just we'll move on. We'll move on, okay. Alright, that's going to go up by X as well, so that's done. Alright, man, it's a struggling question. I struggle doing this question because it's so many colors. These colors are, yeah, confusing me. Anyway, let's see how we can manage. Hopefully next question is going to be better. All right, see you soon. Bye.